Hello dear friends, I'm Mohammed Reza Kachuyan, technical expert at Radonix company, and I'm happy to welcome you to part 4 of the Radonix software tutorial. In our previous session, we explored the main elements of the CAM Pro software interface and explained the basic function of each button. Now, before we dive into the detailed settings, it's important to first take a look at two helpful tools, the Radonix controller test and the Radonix remote test software. These are automatically installed along with the main Radonix software package. To find the test software after installation, simply go to your Windows drive, usually C. Open Program Files, then the Radonix folder, and finally the CAM Pro folder. Inside, you'll find the test software ready to use. When you open it, you'll notice the word Connection at the top left of the window. If your connection and IP settings are correct, the online indicator light will start blinking. For ProUSB controllers, make sure the online mode is set to USB. And for ProLAN controllers, set it to LAN. Now, let's quickly go over the difference between LAN and USB cables. LAN, short for Local Area Network, uses cables with 4 to 8 twisted pairs and RJ45 connectors on both ends. On the other hand, USB, which stands for Universal Serial Bus, is an industrial protocol designed for data transfer. And here's an important reminder: never run two Radonix software programs at the same time. If you do, one of them won't be able to connect properly. So always make sure that all other Radonix programs are closed before running the test software. Now let's move on to the second section called Activation. This part includes serial, A-code, active access, and option. When your controller is properly connected, you'll see a 5-digit serial number appear next to the word serial. For example, it might show something like 24436. Next, when you enter the A-code, which is a 16-digit activation code, the software will display the number of active axes in the active axis section. For instance, if 3 axes are active, you'll notice that the axis icons change from gray to bright right after you press enter. There's also a small box with the letter S, which stands for servo on. Clicking this box will power on the motors. If the wiring between the controller and the drive is correct, the servo on and ready LEDs will light up both in the software and on the controller board. You can also manually move the motors directly from the test software using the plus and minus buttons. Holding the plus button will rotate the motor in one direction, and holding the minus button will rotate it in the opposite direction. Important note: if the motor moves in the same direction when you press both buttons, that means the wiring is incorrect. This kind of wiring error can damage the IC, so the controller will need to be sent to Radonix for repair. Next, let's talk about the digital inputs. Digital inputs are labeled with the letter I, for example, I5. These inputs are optically isolated, which means they're protected from electrical interference, and they have low impedance around 3 kilo ohms to help reduce noise. Each group of 8 inputs has a small switch that lets you choose between NPN or PNP mode. You'll use PNP mode when your sensor has a PNP output, and you'll use NPN mode when your sensor has an NPN output. Now, in industrial automation, these two terms have simple meanings. NPN, also known as low active, means the LED turns on when the input is connected to 0 volts or ground. PNP, also called high active, means the LED turns on when the input receives positive 24 volts. Now, just to clarify the difference between Radonix models, in the Smart series, the PNP and NPN configuration is done through wiring, not by using switches. Also, Smart controllers include analog inputs, while in the ProLAN series, there are no analog inputs available. And when it comes to digital outputs, in the ProLAN controllers, all outputs are NPN type only, but in the Smart series, each output can provide both 24 volts and 0 volts, depending on how you wire it. In this demonstration, we've set the input mode to NPN. So, when we trigger input number 8, by connecting it to 0 volts, the LED for input 8 lights up green both on the test software and on the Radonix controller board. After reviewing the digital inputs, let's now move on to the digital outputs of the Radonix controller. In the test software, digital outputs are shown under the section called Output Port, and on the Radonix board, you can see them located at the lower part, just like in the image on your screen. Each digital output is labeled with the letter O, followed by a number, for example, O2 or O9, which indicates the output number. These outputs are protected against short circuits and the heat caused by excessive current. If any of these conditions occur, a red LED labeled O error will light up on the board, and the controller will automatically disable all outputs. You'll also see the output fault light turn red inside the test software. Each output can supply up to 300 milliamps of current. So, if you need to power a component that requires more than that, you must use an external driver or relay. It's very important not to connect the outputs together, either to increase current or to create logic circuits. If you do, the controller will detect it as a fault condition and will immediately shut down all outputs to prevent damage. All Radonix digital outputs are NPN type, meaning that when they're activated, they connect directly to ground 0 volts. To check that the outputs are working properly, simply click on each box in the output port section of the software. The corresponding LED on the Radonix board should light up when the output is active. Now, let's move on to the analog outputs. Radonix controllers include two analog outputs, labeled A1 and A2. These outputs produce a continuous voltage between 0 and 10 volts, which is commonly used to control the spindle speed on router machines. They're protected against short circuits and static electricity, but connecting them to a voltage higher than the controller's supply can damage the output circuits. In the analog section of the test software, you'll see two scroll bars ranging from 0 to 100. Setting the scroll bar to 0 gives 0 volts, and setting it to 100 gives 10 volts. To test these outputs, you can use a multimeter. Connect the black probe to GND and the red probe to A1 or A2, and you'll see the output voltage change as you adjust the scroll bar. The controller also provides PWM outputs, which stands for pulse width modulation. The PWM voltage is always half of the analog voltage. For example, if A1 is set to 5 volts, then PWM1 will output 2.5 volts. So the maximum PWM voltage is 5 volts. Now let's take a look at the clock, also known as the timekeeper section. This part of the software is designed to test and activate the controller's internal clock. To enable this feature, you'll need to enter a special 16-digit key called the T code or timekeeper code. It works similarly to the A code you entered earlier. Once the code is entered correctly, the clock and timed lock functions of the controller become active. Before pressing the update button, make sure your computer's date and time are set correctly. When you click update, the time displayed in the software will synchronize automatically with your PC's system clock. Important reminder, if your computer's time or date is not accurate, the timed lock feature, which we'll cover in a later lesson, will not function properly. And that brings us to the end of part 4 of the Radonix controller software tutorial. I hope this session has been clear, informative, and helpful for you. Thank you for following along, and we'll see you in the next part of the series.